Are you trying to figure out whether an expression is a certain factor of a polynomial function? Well, you've come to the right place, my friend. Sit back, relax, pop open a nice cold glass of water, and we're going to start. So what this problem is going to entail, it's asking us whether this expression here, x plus 3, is a factor of this polynomial function, negative 4x cubed plus 5x squared plus 8. Now, what does it mean to be a factor of something? Well, very simple. Imagine I have 20, and I'm going to divide it by 10. What does that work out to be? That works out to be a nice value of 2. Okay? We then say, since the answer here is a whole number, there is no decimal component to it, the value that we're dividing by is a factor of 20. So in other words, 10 is a factor of 20. Right? But if you had, like, let's say you plugged in 3 or something like that, this does not work out to be a nice even number, right? It works out to be 6.6 repeating. Once it has a decimal, we know that it's not a whole number, and therefore 3 would not be considered a factor of 20. So, how does that help us solve this problem? Well, if the value that you're dividing by has a remainder, then it's not a factor. But if the value you're dividing by, let's say 2, does not have now a decimal, the answer, in other words, it's an exact value, it's a whole number, in other words, it does not have a remainder, well then this thing would be a factor. Okay? So that's the goal. What we got to do is determine whether, when I divide this into that, whether there is a remainder or not, and we're going to use the technique of synthetic division to help us out. Bam. So the first step here is going to be to develop your synthetic division table, and we're going to do that by identifying the highest term inside of our polynomial function. In this case, it's going to be a 3. You're going to add 1 to it for a total of 4. That's going to tell you how many columns you're going to have here inside of your synthetic division table. Okay? So now once we have that, I know that I'm going to need 4 coefficients. So when I look, though, at my polynomial function, I only have, 3. What that means is that there's a term missing. Now notice there is a certain pattern here. It goes x cubed, x squared, and then there should be an x term. Okay? Now, if that's missing, whenever a certain term is missing, all you're going to do is write plus 0 and then that missing term of x. Because this is like adding 0, right? 0 times x is just going to be 0, and adding 0 to this thing is just going to be 0. It doesn't do anything, right? So therefore, I now know, where did the x go? There it goes. I now know the coefficient of the x term. So now all you're going to do is plug in your coefficients. Always start with the highest power of x, so the coefficient of that is going to be a negative 4. Next one is going to be a positive 5. The one after that now is the 0, okay? And then the 8. Great. Next, you're going to take your what's known as the divisor, and you're going to set that equal to 0. You're going to solve that for x, and what this allows you to do is it's going to allow you to determine the value you have to plug in here on the outside of your synthetic division table. Now, once you have this top row filled out, all you're going to do then is take this first coefficient, drop it straight down, so negative 4. Then what you're going to do is you're going to multiply this value by the outside value of negative 3, so negative 4 times negative 3 is going to be a positive 12. Then just add these terms together. So 5 plus 12 is going to be a magical 17, right? Magical 17. So now what you're going to do is then you're going to take this term now. You're going to repeat the process, take that term, multiply it by the negative 3, okay? You're always going to be multiplying by that outside value, and you're going to plug in its value right there in the next adjacent cell. So this should be 51, right? Hopefully I did that correctly. So 51. Then you're going to simply add this on together. Oh boy, now we got a 51 here. So now we got to take this value. We can already probably see where this is going, but we're going to take this value now and multiply it by the negative 3. That's going to work out to be a, how did that turn out to be a positive? That should have been a negative. Whoops. Well, that's why you're always constantly checking. Anyway, negative 51. And still not going to make a darn difference here, you'll see. But negative 51 multiplied by negative 3 is now going to be a positive, and that's going to be a positive 153. Add these terms together, and that's 161. And this is the value we're looking for. That's why it's in a green box, ladies and gentlemen. If this value is not a 0, remember that this value represents the remainder. So if this is not a 0, what that means is that there is a remainder. And if there is a remainder, that means that this thing does not divide evenly into that thing. Okay? If this were a 0, then I would say that this is a factor. If this isn't a 0, then this is not a factor. So the answer to this problem is basically no. Nope. not going to be a factor. All right. Thank you guys so very much for tuning in. Really do appreciate it. If you can, like, subscribe, maybe even tell some of your classmates. We'd love to help you out with more stuff, and we got thousands of other videos out there, not only in mathematics here, but physics and chemistry as well. We'd love to help you with more. Check us out. Take care.